Hi everyone, welcome to The Edge. Continuing with trigonometry general solutions, here we are asked to get the general solution of cos 2y minus 13 sin y plus 6 is equal to 0, right? We know that with general solution, we want to isolate a single trig ratio. We don't want two trig ratios. And here we can see that we have two trig ratios. We have both cos and sine. We only want one if we're going to solve for a general solution. So let us go ahead and manipulate this equation in a way that we're going to only end up with one trig ratio. Look here, we have a double angle. Here we only have 13 sin y, and here we just have a number. So the only thing we can change here is the cos 2y. We can change it to our convenience. And we know that we have double angle formulas. We have three forms for cos 2 angle. In our case, cos 2y. So which form do we want to change it to? Remember, the aim is to get to a single trig ratio. So we want to use this one because we already have a sine, and we can change this cos to an expression that is only going to have sine. We don't want the one that has cos and sine or only cos. We want to stick with one thing. So if we change to a sine and we already have a sine here, it's going to make things much more bearable, right? So let us go ahead and use this one. It's going to be 1 minus 2 sine squared y. Remember, there a is our y. Cool. Minus 13 sine y plus 6 is equal to 0. Further brush it down, it's going to be 2 sine squared y minus 13 sine y. 1 plus 6 is equal to 7 degrees. Cool. Let us go ahead and factor out this negative. So it's going to be 2 sine squared y plus 13 sine y minus 7 is equal to 0. If you divide negative on the right, anything divided by 0 is just going to be 0. So, okay, it looks like we have to factorize this. We have sine squared y, we have sine, and then on the third term we don't have a sign, just a number. So we can say that sine y is equal to x, and if we say it's equal to x, we can rewrite this as 2x squared plus 13x minus 7. Now it looks easy to the eye, right? And when we factorize, we're going to get 2x squared here minus 7 here, the middle term on the right, x 2 1. We have 7 here. Cross multiply, 2x multiplied by 7 is 14x, positive 14x. X multiplied by negative 1 is going to be negative x, and indeed minus 14x, no, positive 14x minus x is going to be 13x. So we can use these, and we can somehow substitute the x back to sine y, right? So we're going to get 2 sine y minus 1, another bracket, sine y plus 7 degrees is equal to 0. We're going to have 2 sine y minus 1 is equal to 0, or sine y plus 7 is equal to 0. Sine y is equal to a half, or sine y is equal to negative 7. So in essence, we have to get the general solution for both of these. Looks like we're running out of space. Let me just shrink everything. So let's start with sine y is equal to half. Sine y is equal to half. Y is equal, firstly, we get our reference angle, right? It's going to be 30 degrees. If you punch it in your calculator, shift sine of a half, it's indeed going to be 30 degrees, right? And then we see, okay, cos diagram, in which quadrant is sine going to be positive? It's going to be positive here and here, but here we already dealt with it. It's going to be 30. So our first solution would be 30 degrees plus k dot 360 degrees. K is elementary to z. Remember, once you state it once, you don't have to state it again. And then here in the sine quadrant, we know that its form, it's 180 degrees minus reference angle. So we're going to say y is equal to 180 degrees minus the reference angle plus k dot 360 degrees, which is going to be 150 degrees plus k dot 360 degrees. There are your two solutions for sine y is equal to a half. Let me just say that this is 1. Then number 2, sine y is equal to negative 7. Already this is going to be undefined. Or you can say no solution. Why? Opposite over hypotenuse, or x over r. So we know that the r, when we draw a triangle, let me draw a triangle here. This is x, y, r. R has to be greater than x or y. It always has to be greater than x or y. In this case, if we write this -7 as -7 over 1, because anything divided by 1 is going to be 1, we're saying that our x is -7, right? Our r is 1. Okay, so this is x, this is r. In this case, okay, let's ignore the sign for now. The sign is just direction, right? Let's put that negative there. But yes, 7 is the x, 1 is the r. It would mean that 7 is here and r is 1. That doesn't look right. R always has to be bigger than y or x. It always has to be bigger than y or x. Otherwise, you're going to get undefined. So essentially, how I was able to tell that it was going to be undefined right on the spot is because I could see that the fraction has to be in such that, okay, let me say it has to be less than 1. And yeah, it's greater than 1. Because if it's less than 1, it would mean that x is smaller than r. If this is greater than 1, in this case, we can see that 7 is greater than r. Excluding the negative, the sign. Remember, don't look at the sign. Don't pay attention to the sign. It's 7. It's greater than 1. But if it was 0 point something, 0 point something, immediately I was going to tell that, okay, we were going to get the solution. But because it's greater than 1, it's no solution. Greater than 1 would mean that, okay, x or y is greater than r. So for sine and cos only, when you get a number bigger than 1, you must know that, okay, there won't be a solution. But with 10, we know that 10 is, let me write it here, 10y is x over y. So y can be bigger than x, or x can be bigger than y. It wouldn't matter. Even if x is way much bigger than y and y is way much bigger than x, it wouldn't matter. Just as long as this hypotenuse is bigger than x and y. That's what you should remember. That's the trick in which I can follow, to see, okay, am I immediately going to get an undefined solution or what is going on? In this case, I saw that, okay, without looking at the sign, this number is bigger than 1, so no solution. And it's a sign, even if it was a cos. But if it was a 10, we were going to be fine. There was going to be a solution. And yes, that was just food for thought. Yeah. Just, otherwise you can just always keep on using your calculator to make things much easier. But I just wanted to explain that so that things can just make much more sense, right? And yeah, thank you.